Okay, let's start with a big one. What if there was a single recipe for everything? I mean, a fundamental cosmic equation that cooks up all the incredible complex patterns we see in the universe.
I mean, just look around you. Or, look out into space. We see these unbelievably intricate patterns everywhere, right? You've got the majestic swirl of a spiral galaxy, the delicate double helix of our own DNA, the almost mathematical branching of a tree, or the perfect symmetry of a tiny crystal. On the surface, they seem totally unrelated. I mean, they're born from completely different forces at wildly different scales.
But what if they aren't unrelated at all? What if all those things are just different expressions of the exact same underlying process? Now that is the mystery we're going to dive into today, the secret origin story for the patterns of reality itself.
Okay, so how could we even begin to tackle such a mind-bending idea? Well, the clue actually comes from a brand new and honestly pretty fascinating piece of research. So this new scientific paper proposes something they call a generative framework for structure formation. Okay, fancy words, but here's the core idea. What if there isn't a unique blueprint for every single thing out there? One for a tree, one for a galaxy. What if instead there's a universal process, a set of rules that just allows these complex structures to bubble up and emerge naturally, right out of chaos?
The central idea here is actually pretty intuitive, and it all revolves around this powerful analogy. Let's call it the cosmic filter.
Right, so in physics, this filter has a technical name. It's called the Lagrangian. But for our purposes, just think of it as a set of mathematical rules for reality itself. It's like a cosmic sieve or a filter. The universe is constantly throwing every possibility imaginable at it, all kinds of chaotic, random, unstable fluctuations. And the Lagrangian's job is to filter all that junk out, allowing only the stable, coherent, and, resonant patterns to get through. And those patterns that make it through, that's what becomes our physical reality.
The paper actually has this great line that puts it perfectly. It says, "The universe explores all seats. The Lagrangian acts as a filter that prunes incoherent evolution." Think about what that means. It's not about designing a galaxy from scratch. It's about creating a system, a set of rules, where a galaxy is one of the very few things that can stably exist in the first place.
So what does this filtering process actually look like in practice? How do you get from pure static, from total noise, to the elegant, ordered structures we see all around us? Okay, so this schematic here comes straight from the paper, and it basically shows us the whole process in action. Look over on the far left. That's where it all starts. Pure, random noise. That represents the universe of all possibilities. Then, the filter kicks in and selects a specific spectral band, basically a narrow range of potential patterns. Then, in the middle, those possibilities start to take shape and, they compete with each other, until finally, on the far right, only the stable, final forms are left standing. These are what the scientists call eigenmodes. So yeah, we can really break this whole thing down into 4 simple steps. Step 1, you start with random noise, just total chaos. Step 2, you apply the cosmic filter. That's our Lagrangian. Step 3, the patterns that actually make it through the filters start to compete for energy and stability. And finally, step 4, the winners of that cosmic competition emerge as the stable forms we actually see in the universe.
And that third step, the competition, it is incredibly dynamic. The paper calls it the nonlinear growth stage. Just look at this image. All that background energy, all those random fluctuations, are being funneled into one dominant emerging spiral. It's this beautiful, energetic struggle where order is literally wrestling its way into existence right out of the background noise.
And here it is, the final result. After all that chaotic competition, you're left with a single, coherent, stable pattern. That's what the paper calls a bound eigenmode. It's a survivor. It's a structure that is perfectly, and I mean perfectly, in tune with the fundamental rules of the universe.
So, okay, we've got this beautiful abstract theory, right? A filter that creates stable patterns from noise. But let's get back to the real world. How does this connect to the things we actually see?
Which brings us to the big question. If this one filtering mechanism is truly universal, what specific real-world patterns can it actually create? Is it really the one recipe for everything?
And this table, which comes straight out of the paper, is, it's where it all clicks. It's mind-blowing, honestly. On the left, you have these incredibly diverse structures, and on the right, that's their mathematical description, what the paper calls their wavefield representation. And this is the whole idea in a nutshell. Each one of these things, From the immense spiral arms of a galaxy to the tiny, delicate double helix of our own DNA can be described as a stable wave that has survived that cosmic filter. It's the same fundamental process. The same Lagrangian, just with different settings, can generate the fractal branching of a tree, the winding paths of a river network, and get this, even the tiny temperature fluctuations in the cosmic microwave background, the oldest light in the universe. It's like finding a single, unified recipe book for all of reality.
But the implications here go even deeper than just patterns. This might hint at the very nature of matter and energy itself. Yeah, this theory doesn't just stop at big, visible patterns. It suggests that even fundamental particles, the very building blocks of matter, might be emergent properties of this process. So on the left, you see something called spinnerization, which hints that maybe particle spin isn't an inherent property, but just the result of a stable, twisting geometry in space-time. And on the right, toroidal confinement shows energy locking itself into this stable donut shape. It makes you wonder, maybe matter itself isn't really a thing, but just one of the fundamental stable shapes that energy is allowed to hold.
And again, the paper just summarizes this so well. Quote, "Stable physical structures are attractors. Natural forms are resonance fixed points." Let that sink in. What we call nature is just the collection of patterns that happen to resonate perfectly with the underlying rules of the cosmos. They're like these little islands of stability floating in a vast ocean of infinite, chaotic possibilities. So the crucial point, the big takeaway, is this massive shift in perspective. Maybe the universe wasn't built like a house with a blueprint. Maybe it was distilled. Physical reality might just be what's left over, the beautiful, complex, and stable stuff that remained after a universal filter pruned away everything else that was unstable and couldn't last.
And that leaves us with one last, really fascinating question to chew on. If our reality is just the collection of stable patterns that have been found so far, what other forms, what new kinds of resonance are still out there, just waiting for the right conditions to finally emerge?